students, so here we are with the question first of the exercise 1.4 of the chapter real numbers. So the question first is, without actually performing the long division, state whether the following rational numbers will have a terminating decimal expansion or a non-terminating repeating decimal expansion. And the numbers have been provided in parts. So before getting into this question, let us learn what the rational numbers are, as it's been given that all the numbers given here are rational numbers. So what the definition of the rational number says, a rational number is a number which can be expressed in the form P by Q, where P and Q belongs to some integer, and also the HCF of the number P and Q will be equal to 1. What it means is that they are co-prime numbers. Okay, so a number which can be expressed in the form P by Q, where P and Q are some integers and the HCF is equals to 1, are known as co-prime number. And also, if we are able to represent the denominator in form of 2 raised to power n into 5 raised to power m, where n and m are positive numbers, then such number will be having a terminating decimal expansion. So here we are specifying the condition for a number to have a terminating decimal expansion. So what the condition is, so the condition says that if we are able to represent, or if we are able to write the denominator in form of 2 raised to power n into 5 raised to power m, where n and m are some positive numbers, then that number will definitely have its decimal expansion to be terminating. But just keep in mind this point, that the denominator should only be in terms of the factor 2 and 5 only. There should not be any other factor except these two numbers, that is 2 and 5. If there happens to be another factor along with 2 and 5 factors in the denominator, then that number will have non-terminating decimal expansion, right? And if any of the two factors is not present, then it can be represented as 2 raised to power 0, say if 2 is not present in the denominator, or we can write 5 raised to power 0 if in case in the denominator 5 factor is not present. Let us understand this by doing some example. Let us take the example of the number 5 by 35. Now in this number, the denominator can be written as 5 into 7, right? And as we can see, in the denominator, we have a factor 5 and 7, but we don't have a factor of 2. So in order to have a factor of 2 in the denominator, we can write 2 raised to power 0. That don't make any difference, right? So into 5 into 7. Now if we clearly observe the denominator, we have factor 7 along with the factor 2 and 5. So as we know, if in the denominator there comes another factor along with the factor 2 and 5, then that number will definitely have a non-terminating repeating decimal expansion. Got it? Now let us take another example. Let us take an integer 7. The integer 7 can also be written as 7 by 1. Means 1 is in the denominator, that don't make any difference, right? And the number 1 can also be written as 2 raised to power 0 into 5 raised to power 0. As 2 raised to power 0 is equal to 1 and 5 raised to power 0 is also equal to 1. So 1 into 1 happens out to be 1. So this will result into a number 7. And as we observe the denominator, we have only the factors 2 and 5 in the denominator, so which results into its decimal expansion to be a terminating decimal expansion. Clear? Now coming to the question. Here in A part, the number provided is 13 divided by 3125. Now performing the prime factorization for the number 3125, it can be written as 5 raised to power 5 into 2 raised to power 0. And as in the denominator, we have the factors of 2 and 5 only, so its decimal expansion will be, yes, terminating decimal expansion. Now coming to the B part, here the number provided is 17 by 8. So performing the prime factorization for the number 8, it can be written as 2 raised to power 3 into 5 raised to power 0. So which means that only the factors 2 and 5 are present in the denominator, which results into its decimal expansion to be a terminating decimal expansion. Now coming to the C part, here the number given is 64 by 455. So performing the prime factorization for the denominator can be written as 5 into 13 into 7. And as we can see, the factor 5, 13 and 7 are being present in the denominator. So the factor 13 and 7 will result into its decimal expansion to be a non-terminating decimal expansion. Now coming to the D part, here the number given is 15 by 1600. So performing the prime factorization for the denominator, which can be written as 2 raised to power 4 into 5 raised to power 2 into 2 raised to power 2. So as only the factors 2 and 5 are being present in the denominator, which are raised to the positive number power, so which will result into its decimal expansion to be a terminating decimal expansion. So now coming to the E part, here the number given is 29 by 343. So performing the prime factorization for the denominator, that is the number 343, this can be written as 2 raised to power 0 into 5 raised to power 0 into 7 raised to power 3. And as the factor 7 raised to power 3 is being present in the denominator, which will result into its non-terminating repeating decimal expansion. Now coming to the F part, here the number given is 23 by 2 raised to power 3 into 5 raised to power 2. As only the factor 2 and 5 are being present in the denominator, which are raised to the positive number power, so it will result into its decimal expansion to be a terminating decimal expansion. Now coming to the G part, here the number given is 129 divided by 2 raised to power 3, 5 raised to power 7 and 7 raised to power 5. As along with the factor 2 and 5, 7 is also present in the denominator, so it will result into a decimal expansion to be a non-terminating decimal expansion. Got it? Now coming to the H part, here the number provided is 6 by 15. So performing the prime factorization, or we can say simplifying the numerator and the denominator and cancelling the common factor in them, so it will be reduced to the form 2 by 5, which can also be written as 2 by 5 into 2 raised to power 0. And as only the factor 2 and 5 are being present in the denominator, so it will result in its decimal expansion to be a terminating decimal expansion. Okay. Now coming to the I part, here the number given is 35 by 50. So simplifying this form and cancelling the common term, it will result into the number 7 by 2 raised power 1 into 5 raised power 1. As only the factor 2 and 5 are being present in the denominator, so its decimal expansion definitely be a terminating decimal expansion. Now coming to the H part, here the number given is J part, here the number given is 77 by 210. Performing the prime factorization for this number and simplifying it, it will result into 11 by 30, as they have the factor 7 common in both the numerator and the denominator. So prime factorizing the number 30, which can be written as 2 into 3 into 5. As we can see, the factor 3 is also present along with the factor 2 and 5 in the denominator, which will result into its decimal expansion to be a non-terminating, repeating decimal expansion. Alright, so this was all about the question first of the exercise 1.4. I hope this question is clear to all of you.